The core of our application's business logic is stored in what's called an entity or an aggregate. I use those terms often interchangeably, and I realize that there are distinct differences between the two, but in our case in Glee2, we actually only have aggregates, but I'm so used to calling them entities that sometimes I slip. So let's just go into our example entity or aggregate, and I'll show you around a little bit, show you what's going on, and explain a few things. I'm actually going to show you the aggregate root, the abstract class that it inherits from also. You can even see entities is the name of the folder where this is located. So I'm going to F12 into this aggregate and just show you a few things. So this class has a few properties and methods on it. One is the first one is the list of events. These are domain events. When things happen on an aggregate, those things should trigger domain events. The domain events are what happen as a result of changes. They're named in past tense, and they represent something that has already happened in the past. So, for instance, if you change the name of an employee, then a domain event will be created that's called employee name changed. And then that event will be thrown out into, you could imagine it's being thrown out into the air for anybody to be able to pick up on and listen and do something with. Almost like a radio signal, these domain events send out they transmit a radio signal to the rest of the world saying, hey, this thing happened. So in the course of one session with the entity, with the aggregate, you may do 5 things, and before you send it into the repository to finally save it. And so that means that those 5 things should result in 5 different domain events. And so this method, sorry, this property called domain events will build up more and more and more things as you make more and more changes, and they all get stored here inside this domain events collection. Another thing is that as you can see here, this aggregate has a generic TP key. The TP key is just the key that we're going to use, and so you can see here that this is the primary key that eventually goes into the database. And so this right here is a public abstract TP key ID, which means since it's abstract, it has to be implemented on the child class. So anything that inherits from this aggregate has to have an ID on it of some sort of type. So we use GUIDs, so that means that on our employee, you'll find that there is an ID of a GUID type. It also has a couple of methods on it. One is called new change, in which we will see in just a few minutes, but this new change takes in a domain event and it adds it to the domain events. As you can see, it just adds it to our list, and then it returns the actual domain event. So it's kind of like a pass-through. We also have a method, or sorry, a property called removed, which is basically putting on all of our aggregates a property that helps us to see whether it has been removed or not. You could even rename this to archived if you wanted to. We try to never delete anything from the database. Never really delete anything. It's better just to hide it. So we have this right here to help us hide the things that we don't want to see anymore. As just a piece of advice, if you want to be able to hide things that are removed, you may have to filter to remove those removed items. And then here is a method that is used usually only by our repositories. So the repository, before it saves or after it saves, it wants to see what kind of changes have been made, and so it's going to get all the changes that have happened, and then it's going to also clear the domain events list. So that is our aggregate. So let's go back to the employee and see how it is implemented using the aggregate. So we have a protected constructor here because, and you'll see a few other protected things. Protected basically just means that this thing, whatever it is accessible to anything that is inheriting from it. So if we were to inherit from employee, we would be able to, inside of that inherited object, we'd be able to use this constructor. It's not publicly available, so if you just do new employee somewhere, that employee doesn't have access to this constructor, would have to use this constructor instead. The reason why this is helpful is because when we are mocking or faking the employee object, we need to be able to have a parameterless constructor that is accessible. And mocking and faking tools typically use inheritance in the background. So here you can see there is a constructor, and this constructor is only used when we are actually creating an actual real new employee. In this case, you can see there's a new change, which is the method that we saw on the aggregate. I'll show you that one more time. New change, remember it only takes in the domain event and it adds the domain event to the list, and then it returns the domain event. So nothing special, nothing super crazy going on there. But you'll see here that we are doing new change. We say when new change. The when comes in just a few minutes. I'll explain that. The new change is going to log this domain event. Now, I said before that a domain event represents something that has already happened, but that is to the outside world. In the inside of our employees entity, we're actually going to use the employee created as a way to trigger the change internally. So this employee created is just a very simple object with a lot of properties. You can see lots and lots of properties. They are all the same properties that are necessary to create the employee in the first place. And you can see it's got a lot of these. These are public properties or public getters. I do have a protected set, which means at some point we needed to be able to fake this, but the setter is actually protected, is not accessible publicly. So here, this is just another POCO employee created. There's nothing crazy going on. It's kind of like a DTO in a way. It's encapsulated, so we're not able to mutate this, mutate the values of this after it has been instantiated the first time. So we're saying when new change, employee created. So we are going to expect that these arguments are actually, or these properties are going to change the values of the employee property at some point. That happens in the when. So you'll see in our employee entity that when new change is pretty much how you make every change to the employee. So we don't want to actually make changes to the employee itself inside of this constructor or inside of one of our public methods. Instead we want to cause that change in a private method. So here the when is here at line 25. And you can see it's really just bouncing these properties back and forth until it finally updates the properties of our employee using the values from the event. So why do we do it this way? Well, for one thing, by doing it this way, we are forcing ourselves to transmit a domain event out to the outside world that the employee has been created. Not only are these values useful to then update the properties in our employee, but those exact same values are going to go out to the outside world and notify that, hey, there's this employee with this ID and this first name, this middle name, this last name, blah, 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 that has just been created. And so we kill two birds with one stone by doing it this way. And you can see here, like I said before, we don't make the change in a public method. We only make the change to the employee in the private method. So you can see here, this void when is actually a private method. So let's scroll down just a little bit. These are our properties for our employee. You can see that they are virtual. You may not have seen this keyword before, but the virtual keyword is used mostly for entity framework. It doesn't really change much of any of the behavior in the rest of the code base, but it does make this entity accessible to the entity framework so that it can populate the values of these when it's getting the employee out of the database. So it goes in and just populates these things. You'll notice over here that we're setting some default values. This is to help us deal with or prevent null exceptions. When you start working in Glee2, you'll notice that there are several things that prevent nulls. So this is how it deals with it, how it prevents those nulls. If I don't have this, then I'll start getting build exceptions or build errors. The setter is protected. It's not public. We never want a public setter, especially on an entity, because we don't want this thing mutating over time. We want to be sure that that the values are not being changed. So a protected setter allows, once again, those mocks and fakes to be able to access the setter, also the entity framework, but it doesn't allow any of our public code, or they're not available publicly. You'll also notice here that this string is nullable, as signified by that question mark. So that means that we don't have to set a default value, but we have said that this is a nullable value, which means that the compiler is going to require us to do null checks on this value. Scrolling down. So here, let's look at this real quick. We're going to remove. So this is a public method that is being used by probably a command handler. So it's going to do employee.remove. When it does employee.remove, in the background, it's going to do when new change employee removed ID. Taking a look at this event, it is super simple. It's got a public getter for the employee ID and a public constructor so that we can instantiate that in the first place. So here we are instantiating it using that public constructor, and then we pass that into new change, which of course is just going to add that to the list of domain events, and then our when, which is, it's very nice when these are right below, when the private method is right below the public method. Again, we said that you should never actually make changes to the entity from the public method. You should only do it from the private method. So here we've got our domain event, and we don't really care as much about the value at this point because it's just we're going to set remove to true. But this lets the rest of the world know that employee by this ID was removed. Change names. I'm not going to go through all of these, but I want to go through just a few just to kind of help it sink in. Change names. Same exact pattern. We've got a public method for change names. That way in our command handler, we can just do employee.change names. We can pass in the things, and then the entity itself will handle the rest. When new change, employee names changed. This is going to go out to the rest of the world and notify the rest of the world of the names changed, and then our private method actually handles the mutation of these property values. Same thing with change tags. You're going to see this pattern over and over and over, and this is the pattern that you should follow in your aggregates, in your entities. When new change, employee tags created. Once again, it has all the information that it needs to notify the world what happened. Now, what would happen if I didn't add an ID here? Well, the ID would actually we would be able to notify the world what happened, but if we didn't have an ID on the event itself, then the rest of the world would know that tags changed, but they wouldn't know which employee they changed for. So that's the reason why it's helpful to have the ID on these. Then we have, again, our private method where we make the mutation, and we're going to update the tags with that. Over and over and over, you'll see the same exact pattern. When new change, and then we have the domain event, and then we use the domain event to change new, when new change, domain event, make the change. All through this. This is the heart of your business logic. Now, there may be some, now in this case, our employee is very simple. There's not really any calculations. We're not having to do any kind of decisions on behalf of the business. But sometimes you do. And that decision logic should also be housed here inside of your aggregate, so that it's easy to find and so that it's all in the same place. So that is our employee. That is our entity, our aggregate. If you ever have to create a new aggregate, all you have to do is add it here and make sure that you inherit from this aggregate abstract class.